Today I'd like to talk briefly about what we think of reasonable scale and how we approach that problem at Allegro. So, as I said, we are from Allegro and we are Piotr and Marcin, and we both work in a team doing recommendation systems. And that team is part of a broader organization called MLR, which stands for Machine Learning Research, where we do multiple problems in the domain of machine learning, and that is computer vision, NLP, and translation, like things for search and ranking. So, to start, let me show you this, I think, pretty well-known diagram of a ML system, of a thing that actually leads to a, let's say, successful deployment of a ML system. And what contributes to that is that you need to have a successful deployment, so to speak, that's described in a lot of literatures around the industry. You need some way to orchestrate the model, to orchestrate the trainings, have a sufficiently well-defined data pipelines and alerting and monitor your deployments and do all of the stuff that you actually tend to have for a production-ready system. But in our opinion, this kind of is a bunch of requirements that are driven by really huge companies, and to actually build a system and to deploy them and to have a revenue stream coming from that system, to that system contribute to your company's growth, you don't literally need all those things. To get them implemented in the whole fashion would be really time-consuming and also very budget restrictive, like it would use a lot of budget. So, so to speak, this is very skewed towards big enterprises, and well, this actually means that those big enterprises, we can say, are just a few in the industry. We can say that Google, Amazon, so all the FANGs are in this group. But then this is the left-hand side of this diagram. But we see that this distribution of companies is actually really skewed, and this is like a tail distribution of. There's a tail distribution of all the different companies that actually do a lot of ML work, benefit from those models, from those deployments, but don't have that scale. And yeah, Allegro is one of those companies. We don't have like infinite amount of resources and compute and what's more data, but then there is a way to do that and to do that efficiently. So how can we somehow differentiate between those companies? So this table shows what are the, let's say, most obvious features of FANGs or hyper growth companies as compared to, let's say, reasonable scale. So in big companies, we can say that their models, the way they deploy them, they want to generate hundreds of millions of dollars or something in revenue. For that, they have thousands or even maybe more of engineers that can support that. That's why they can afford multiple stages of deployments, monitoring, and all the MLops that I briefly mentioned before. What scale of data they have? Yeah, that can be petabytes or even more. Of course, they operate also on smaller scale, but like that's what they can handle. And for that, to handle all that, they actually need really a lot of resources, a lot of compute, a lot of financial resources, and we can say actually that their resources are infinite. To compare, well, those reasonably scale companies operate on a much smaller scale. We, let's say at Allegro, we operate at the scale of terabytes, and we still deploy models. We have tens of engineers that can deal with those models, and we are successful in that. So the reason for that, or the approach that we want to describe here, is how to do a lot, generate benefits for the company that you're in with limited resources, not like things that can be done with unlimited budget. So one quick disclaimer that the name, the reasonable scale, is not ours. It was coined by this guy, Jacopo Tagliobue. So he is a really nice guy, really good contributor to the open source, both open source and academic community. And he's a ML systems professor and also Yeah, he's written a lot of papers around the topics of recommenders and reasonable scale, as the term suggests. And here I just pasted 2 of his GitHub repos that you can go to and see what are the templates for that kind of approach. His main reason here is to, like I said before, try to, let's say, evangelize how we can build really scalable and well-defined systems in a constrained environment. To show you how we got to some place of a reasonable scale at Allegro, I would like to go through first the journey that we as a company took, and we did a migration to the cloud. In our case, that was Google Cloud. It happened, or it started a few years ago. It was motivated by the lack of resources or the observation that we can scale better with the cloud offerings that GCP gives us. With that in mind, the migration was successful. We got at our hands really a lot of different tools, a lot of different stack tools that GCP offers. Those are mainly the place that we use GCP is mainly in a data world. But then again, it's really a lot. So you can, for example, get some orchestrations like Kubeflow, Vertex pipelines, deployments for orchestrated deployments, or feature store with data drifts detection, all that. You can get cloud functions to deploy your models or do some like really ad hoc things. So like as a developer, as a ML researcher or deployer, you get access to a lot of different tools, a wealth of them. And in that cases, in those situations, people tend to get really fun with those tools, and it's really nice to use them. But with our approach, we moved to the cloud. It gave us a lot, but it also we also brought a lot of old habits with us. And to be frank, what we did was at first just like a lift and shift migration. So we took our things that were working in an on-premise cloud and migrated them, almost not changed to the cloud world. And yeah, like I said, it worked. It was okay. But then just to give you one example, we did a lot of things with Spark, because we started a long time ago with Spark, when the data was like big and the compute was not that big. We needed Spark to scale. We needed Spark to do analytics, some models and stuff like that. But when you migrate to cloud, you actually can do better, and you, well, not exactly need to rewrite all your Spark jobs to something else, but you can. You can use that to increase your velocity or increase the way you can experiment. So why we did that? That comes from one observation that those few years ago, what we named as a big data actually is not big data right now. In many cases, what happened to be like a part of internet that we wanted to train the model on, or part of the data of the company that we wanted to use in our trainings, now seems like a really small thing. And so even though internet grew, so the amount of data grew enormously, the amount of data that you need to train your models may be not that big and may be consumed by the increased compute efficiency that happened during that time too. Of course, that's not to mention things like large language models, but then they are not the only thing around. So coming back to the journey that we had, with all the tools that happened around that we started to use, there started to be those observations that it's actually a big problem. It becomes hard to iterate with speed, with efficiency, having all those tools deployed. So, for example, it's hard to run trainings locally, or hard to, like I said, work with data sets that are only served by Spark jobs. And like you can get a lot of different small jobs deployed to your orchestration, but then they all incur small startup time delay, and that increases your training speed. So all those things mean to us that, well, you can do smaller increments and slower than you would otherwise. And that's what reasonable scale means. And those pillars of ML at reasonable scale, one is about doing more with the data that you have and doing that faster. So instead of increasing the volume or the scale of your compute by adding more cluster nodes or more like defined technology, you can add more data, but then transform that data more in a smarter way. You don't need to maybe buy new hardware or buy new instances. Maybe you need to process them in a smarter way. The same goes for pass and fast approaches. You, of course, can do that. There are places where this is really cost efficient because you don't want to focus your efforts with a small, limited team on things that are not core to your business. But then there are things that you really need to focus on. So this means buy what you don't focus on, but that's not core of your business, and work on what's core of your business and where you want to get the money from. And then there's the point about having a scalable system where you can scale with the cloud offerings, but not by adding more nodes, but maybe by adding more smarter technologies and adding better, maybe beefier machines to your setup. So these are like really like from high view pillars of that approach of the reasonable scale. And now Piotr will go through some of the stages of a training pipeline and from the perspective of a more granular approach through those points.
Thank you, Marcin. So I will walk you through some example of ML pipeline at reasonable scale, which here you can see such an example with 5 major points that you will often see. This is model ingestion and process, model transformation, data ingestion and process, data transformation, that also includes feature engineering and test set creation. There is model training, model evaluation, both online and offline, and at the end, model deployment. And all of it is, my point is that just to go through each stage and just show you how you could implement it following the principles that you saw in those four pillars of reasonable scale. So the thing that bounds all of it is orchestrator, and the way you could use it from those cloud tools and debug without, for example, spinning the whole Spark cluster, just to see that something breaks at runtime. So data ingestion and process, the rule is that you don't want to store a bunch of loose unstructured files. You want to use the serverless solutions like Snowflake or BigQuery. You load your data into a structured data warehouse where you can then also transform it in a serverless fashion. You just put there some SQL and you just want the result out. And also this allows you to do it in a reproducible and reliable fashion because data versioning is as important as code versioning. You don't really want to, after 1 year or half a year, just come back and see that you don't have your data set and you need to retrain something or check something and it's lost at that point. Data transformation, so like Marcin said, you don't need Spark. There are a lot of open source tools that you can use to run your data preprocessing and feature engineering in memory, on GPU, accelerated parallel execution data frame libraries that are really easy to use and intuitive. It's like pandas, but for example, you could use Dask QDF. Or you could use polars, which are intuitive to use, very fast to debug, and run on the same machine that you can use for training, right? That you will use for training. Then is model training, and in here you can use, for example, Hugging Face or other data or the model hubs, just to don't rewrite all the complex models and then train them from scratch. And also you don't want to poke around, search through log dirs that are stored somewhere in the cloud or what's worse, on multiple local machines and just in search for a specific results. What you want to do is just to go to one of the hubs, import the model, maybe take the pre-trained weights and just then fine-tune it. Use also some integrated tracking tool like weight and biases, Neptune. or other integrated solutions, just to have all the results in one place, so you can compare them, you can get back to them after a long time, have it organized. Model evaluation and deployment. So you really don't also want to send your model to production because it does something and then hope for the best. You really want to run an evaluation, and you want it to be fast and repeatable. And also you want to track metrics that are online and offline correlated. I know that it's like it might be hard, but you really want to think about it when you are deploying when you are training your solution. You want to think about how it will be used. So, for example, if you know that it will be queried on some data from I don't know 2 weeks, you want to train it and evaluate it in this, and offline evaluate it in this way that it takes data from 2 weeks, and you see how it will be output. So yeah, that's one. Yeah, and also of course A/B testing is very important when your solution is mature enough. So to summarize, you really want to use reasonable scale open source tools to fast iterate in this development stage, but you really want to remember and create the reasonable scale MLops pipeline to and use platform as a service and function as a service, so you can deploy with low effort with your small team. And it comes down to not wait, move fast, break things, focus on what your company is, what is the most important for your company, and buy everything else. So thank you.